What up, Eastview Scholars? Welcome to another edition of Sharp Shorts on the metric system. Let's get started. This morning, as usual, I went on my run and my GPS Garmin watch tells me that I went 8.2 kilometers. I came home, I took care of my stretching and did a little ab work, and then to replenish some of the lost fuel, I guess you would say, or macromolecules I needed, I enjoyed some milk out of this delicious gallon of milk to replenish proteins and stuff that I needed. The reason I'm pointing that out is kind of the basis for our metric system. Why are we talking about this? Well, chemistry, physics, physical sciences, all science are, as we talked about with scientific method and why are we taking chemistry, are observational. They're sciences of observation, and particularly the physical sciences of prediction and mathematics. In any science, just as, say, if you were an airline pilot, the common language is English, we need a common language. If I'm doing experiments and making discoveries and publishing them, somebody else is going to repeat those experiments to prove that I have done that correctly. In order to do that, we need to be talking in the same units and the same language. And so, in science, you hear often what is called SI units, System International de Unités, whatever, butchered French, that says that when we talk about things like length, in science, length will always be measured in a meter or always written and discussed in a meter. Mass, the common unit, is kilograms. Temperature is Kelvin. Amount of a substance is mole. Those are the ones we will most commonly see this year. And so whenever we're all having a discussion from no matter what part of the world you're in, then you can reproduce exactly, hopefully, those experiments and the results in doing so. Now, most of the world, as you'll see, hopefully you laughed at that cartoon, most of the world, as you will see, is using metric system. Here's us in the U.S., and I would say we're a combo platter. We sell liters of soda. We have that little kilometers per hour on your speedometer next to your miles per hour and stuff. But we're not great, Alaska, Hawaii, U.S. The other two reported countries that don't are Liberia right here and Burma or Myanmar, however you want to call it, also. So why is most of the world and why are just a few of us not doing it? Well, look at this graphic. Here's the metric system. Standard measure. Your foot, your yard, your dirty four-letter words like inch, foot, yard. Those were based, the foot was based on a foot. Whatever king or dictator was ruling at the time, his foot was measured and that was the foot. So measurements were changing all the time. The metric system was based on math, base 10 math. It makes it much more simple than trying to remember. There are 12 inches in a foot, there's 3 feet in a yard, there's $20,000 to have a nice backyard. There is 16 ounces in a pound. There's 2,000 pounds in a ton. These things are, and they're not an equal increment away from each other. If you look at the metric system here, and I'm going to get my pen going, and I'm going to tell you right now that the pen feature isn't working amazingly well for me at this moment, but if you look, here's where we start in the metric system. We start at 10 to the 0, or 1. Okay. And it's all base 10 math. And in this area, you don't see any prefixes because this is where our base system international units are. And for length, we'll just say the meter. For volume, the liter. And for mass, we'll just say gram. And that's our base units at 1. Now, how much you have, or the scale of that then, goes in an exponential manner in base 10 off of that. So rather than remembering all these different names and like how much, length, how much is in an acre, and stuff like that, rather than doing that, you keep your base unit as meter, liter, gram, and then its scale is determined by its prefix. So we talked about kilometer. Kilometer is at 10 kilo, that prefix is at 10 to the third, which is 1,000 times more than 1. So a kilometer is has 1,000 meters in 1 kilometer. Kiloliter has 1,000 liters in 1 kiloliter. Kilogram has 1,000 grams in 1 kilogram. If I want to go to the other side of the scale, here's milli vanilli. Milli means 1/1000th, as you can see here, 0.001. So what does that mean? At 10 to the minus third, it means that there are 1,000 millimeters in 1 meter. There's 1,000 milliliters in 1 liter. There's 1,000 milligrams in 1 gram. So the base of the word is the measure that you are covering, whether it's a volume, a length, or a mass in our examples. And then the scale tells you its size in relation to 1. It is much easier to work, and it's much easier to work with. So, for example, I ran 8.2 kilometers. Okay. Hey, pen feature's working pretty well. Okay. I want to know how many meters that was. Well, all I need to do is look at the ratio that there is 1,000 meters. Oops, my division sign got a little crazy, or my fraction, in 1 kilometer. Okay. This is my ratio or conversion fraction. There is 1,000 meters in a kilometer. And as I see, by multiplying my known 8.2 number times this 1,000 over 1, that will, and I wrote in my units, I cross them out with numerator, denominator, cancel out the common thing, and I find out I ran 8,200 meters. Okay. A much easier, or if you wanted to look at it in your exponential way, it just meant on base 10 that was 3 jumps. I'll write it down here. 8.2. That was 3 movements of the decimal point to 3 jumps of the decimal point in base 10 math. And I'm going to the right because kilo is larger than my base unit meter. So there was 1,000 meters in a kilometer, so that number should get larger. Were I making the number smaller, I would have probably moved it towards the left. Okay. So that gives you an idea of why metric and what the metric is based on, and a little bit of math to go with it. And I'm going to do one more thing as a preview for our dimensional analysis. Let's do this. And this is what we would do with gallons if we want to know how many liters. I ran 8.2 kilometers. I want to know how many miles did I run this morning. You know, for me it was a kind of a medium short, a little less than average running day. Well, I need to know the relationship between miles and kilometers, and it happens to be that there is 0.62 miles, which I'm going to abbreviate just MI, in every 1 kilometer. So, previewing our dimensional analysis discussion, oops, my pen just went a little goofy. I wrote in the units so I could see if I just cancel this out, the only units I have left are miles, and then I just do the math. 8.2 times 0.62 over 1 is 5.1 miles. Okay. And we will do more of that to be able to convert between standard and metric in our next video on dimensional analysis. But for now, hopefully this helped as you use it in combo with your book. There will be a few little quiz questions to follow this video also on our Sophia page. I would recommend trying those. But other than that, I would just say for Eastview Scholars, scholar up!